So we want to find the absolute extrema for this function, which is the cube root of x squared minus 9 on this closed interval -2 to 5. So what we want to do is we have the domain for this. This is a cube root function. So the overall domain, if I didn't have this restriction right here, or if I didn't have this closed interval, it would be -infinity to +infinity, okay? So what that means is this is continuous on this closed interval, which means it has to have an absolute min and an absolute max. So what we need to do is we need to find the derivative. So let's do that first. Okay, so the first thing is find f prime. Okay, so now f of x, I'm going to rewrite as, instead of the cube root of x squared minus 9, I'm going to write it as x squared minus 9 raised to the 1/3 power. So that means f prime of x would equal power down, so that'd be 1/3 times x squared minus 9, the inside part of the function, raised to the, and I have to subtract 1 from this, but that's equivalent to subtracting 3/3 from this, which makes -2/3. And then I got to take the derivative of this inside function, so then times, and that would just be 2x, because the derivative of x squared minus 9 is just 2x. Okay, so then this is 1/3 times 1 over x squared minus 9 to the +2/3 power times the 2x, right? So writing this as one fraction, f prime of x becomes 2x over 3 times x squared minus 9 to the 2/3 power. Okay, so then the next thing, we have the first derivative, and now what we have to do is we have to figure out, okay, where is that first derivative 0, and where is that first derivative undefined, okay? So that's the very next thing, is we want to find the critical numbers. Now, this is going to be a big deal. This whole unit is finding critical numbers, okay? They're also called critical values and also called critical points. All three are synonyms, okay? They all mean the same thing, okay? So that means we have to find, okay, so what is it? When is f prime of x equal to 0? Okay, so we got to figure that one out. And we also have to figure out where f prime of x is undefined. Okay, so this derivative is 0. The only time it could be 0 is when this numerator is 0. So that really, that's all I have to do is set the numerator equal to 0. And for where it's undefined is when the denominator is equal to 0. So that'd be 3 times x squared minus 9 raised to the 2/3 power equals 0. Okay, so this is going to happen when x is equal to 0. And 0 is in between -2 and 5, so that's a critical number. And then when I go to solve this, I'm going to divide both sides by this number 3 because I'm multiplying by it. So that would give me x squared minus 9 raised to the 2/3 power equals 0, because when you divide 0 by 3, you get 0. And now to get rid of this exponent, I'm going to raise both sides to the reciprocal exponent. So that would look like this, x squared minus 9 raised to the 2/3 power, close the bracket, I'm going to raise that to the 3/2 power, equals 0 to the 3/2 power. And then the exponent rule here is I got to multiply these, so that makes a 1. So this is going to make x squared minus 9 is equal to, and that would be 0. And then there's two ways you could solve this. One is add 9 and square root both sides, or you should notice this is also a difference of squares. So this factors into x minus 3 times x plus 3 equals 0, which means x is equal to 3 and x is equal to -3. Okay, now, however, if you look, our closed interval is only between -2 and 5. So this point right here, this critical number, is actually not a critical number because it's not in -2 to 5. It's outside this interval. So we're going to ignore that one, okay? So the last thing to do is take the critical numbers along with the endpoints and evaluate them, put them into the function and see what they equal, okay? So the third step in this is to evaluate f of x at the critical numbers and the endpoints. And you're going to see and look and see which one is the biggest and which one's the smallest, okay? So I'm going to do this from smallest to largest, okay? So the smallest would have to be the left endpoint. So that's going to be f of -2. So f of -2 would be the cube root of -2 squared minus 9. I'm going to zoom in a little bit so you can see that a little bit clearer. And then that would be the cube root of, this would be 4 minus 9, so that'd be the cube root of -5. And then we're going to do the next one would be the next critical number, which is either 0 or 3, so the next one's going to be 0, so f of 0. So that's the cube root of 0 squared minus 9, so that would just simply be the cube root of -9. And then the next critical number would be 3, so f of 3. And so that's the cube root of 3 squared minus 9. So that'd be 9 minus 9, 0. And the cube root of 0 is just 0. And then the last one would be the right endpoint. So this is an endpoint. This is the first critical number, second critical number. And then the last one would be the endpoint, f of 5. So f of 5 is the cube root of 5 squared minus 9. Well, 5 squared is 25, and 25 minus 9 is 16. So this would be the cube root of 16. Okay, so now the cube root function, if we know, all right, if we think about the cube root function, we can determine which of these is really the smallest without ever using a calculator. Because remember, I had you graph this. The cube root function looks like something like that, right? And so this keeps going down, 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 right? I should have drawn it that way, okay? Which means as we go to the left, and -9 would be further to the left than -5, this one would have to be lower, okay? So this one's gonna be the absolute minimum, and this one would have to be the absolute maximum, okay? Now, with a calculator, all right, we can put that in, all right, and it'd be the cube root, okay? So clear all that out, okay? And then, so if I press alpha, oops, I pressed the wrong thing, math, and press alpha and go down to number 4, that's the cube root of -5, and then that would give me -1.710. So this turns out, putting in your calculator, -1.710, putting this one into your calculator would be -2.080. This one's definitely 0. And then this one's going to be our biggest one, right? But as a decimal, it's 2.520, putting it into our calculators, okay? So now what you do is you look, okay, which of these is the largest one? Well, this is the largest one. It's the cube root of 16. So that's our absolute maximum. So absolute maximum of the cube root of 16 at x equals 5. And then we also have an absolute minimum. Sorry, my phone's going off. Absolute minimum of, and it'd be the cube root of -9 at x equals 0, because that's what we put into the function to get that, okay? So this is how, without looking at the graph or without having the graph, you can determine the absolute maximum and absolute minimum, which is equivalent to saying the absolute extrema, okay? All right, so now we're going to use technology to figure out the critical points, okay? And that's what we're going to do next. So for this next problem, we're going to use a graphing calculator to find the critical numbers. So that's the key to this, is is using the graphing calculator to find this, okay? Closed interval still, this is a polynomial, so we know it's continuous, okay? And then we want to find the absolute extrema, okay? So the very first thing is we need to find the derivative of this, okay? So f prime of x is equal to 3x squared, and then minus 8x, and then minus 4, okay? So then we need to find the critical values, okay? So to find the critical numbers or critical values, we need to set f prime of x equal to 0, okay? And we also need to find where f prime of x is undefined. All right. So this is going to happen when 3x squared minus 8x minus 4 is equal to 0. And this one actually is never going to happen. So this can't happen because this is just a parabola, right? And we know that the parabola is never undefined. Okay. Also, there's no denominator to make it undefined. All right. Okay. So then to do this with technology, okay, we're going to let this left side be y1, okay? And actually, I'm going to start out by putting the function in, and this is going to be my y2. So I'm going to switch colors, and I'm going to put this into the calculator. This one's going to be my y2, and this one's going to be my y3. And then we're going to look at the intersection, because that's how you solve these graphically, okay? So I'm going to go to my graphing. So what we're going to want to do is we're going to want to press y equals, and I'm going to clear out the function I had in there. And I'm going to type in the original function, which is x raised to the third power, and then minus 4x squared, and then minus 4x, because we're going to need this later. So I might as well put it in now, and then plus 16. Okay, and then for y2, we're going to put the derivative, which is 3x squared, and then minus 8x, and then minus 4. And then y3 is going to be 0. Okay, now I'm also going to go up and I'm going to not graph y1 because that's my function. So I'm going to go on top of the equals and press enter, and that will stop it from graphing. So the only ones that are going to be graphed are the ones where the equals is highlighted, like these two. Okay, now if we look at this, okay, we're only talking about a closed interval. The x is between -2 and 6. So that's our new domain. So I'm going to go to my window, press window. And for my x min, I'm going to type -2. And for my x max 6. Y scale being 1 is great. Y min, I'm going to guess and say, hey, let's try -10. And let's go to 10. There's really no way, unless you just pick a value for Y min and Y max, graph it and see where you wind up. Okay, so I'm going to graph this and see what we get. Okay, so that's pretty good. All right. So right now, this is my parabola. Okay, that's the first derivative. This is where it's equal to 0. So this is telling me right here, that's a critical number. And this is also a critical number. So I have two critical numbers. So I got to find the value here. Okay, and the way I'm going to do that is I'm going to access my calc feature. So I'm going to press second and then trace to access the calc feature. And then I'm going to select number 5, intersection. And then the first curve. So I'm going to press, you got to tell the calculator what two curves you want to find. So the first curve is the parabola. You can look up here. Okay, so I'm going to press enter. And the second curve is my horizontal line. Press enter. And then for the guess, I just need to get close to the one I want to find. And I want to find the one on the left first. So I want to work my way from left to right. And I would really encourage you to do it that way, because then you're going from smallest to largest, okay? So I'm going to press enter. Okay, and so this is telling me my intersection is -0.430501. So rounding, that would be -0.431. Okay, so now what I'm going to do is I'm going to go to my home screen, okay, and I'm going to store this value, okay? Because we're going to want to use this value because that's a critical number. We're going to want to put that into the function, and that's also why I typed in for y1 the actual function, okay? So we're going to press second quit or second mode to get the quit, okay? I'm going to clear out my home screen. Okay, so right now, if I type x, x has been stored as that critical number we just found. Okay, so there it is, negative 0.431, okay? However, when I go to find the next one, my x is gonna be that new one and it'll override this, so I'll lose this number. So I wanna store this as a letter variable. So I'm gonna store it as a, and so I come down here and I press the store button, okay, which is going to take that answer and store it. Or I could also just type X again and press store. So that's going to take my X and store it as, and I want to access my A. So that's in green. So I need to press alpha and then the math key to get A. And if I press enter, okay, now when the X changes, my A won't. My A will stay negative 0.431. Okay, so I'm going to go and I'm going to record this on my paper. Okay. So now on my paper, okay, this was x is about, okay, negative 0.431. And I want to call that a, so I'm going to the side here, I'm going to say, okay, this is my a value. So now the beauty in this is instead of writing this number, I could write a, because anybody that reads your work knows that a and this negative 0.431 are the same, okay? All right, so now we're going to go back and we're going to go and find the next intersection for our graphing calculator. Okay, and so we want to go back to our graph and we're going to find this one right here. So I want to press second trace to access that calc menu, select number 5 for intersect. And again, the first curve, second curve is the horizontal line, but I want to get over here closer to this other one for my guess, okay? And I didn't say this earlier, but I should have. When it says intersection, that means you did everything right. So that when it says intersection, that's the X value we're looking for, okay? So I want to store this one. Now I don't want to store it as A, I want to store it as B. So I'm going to go back to the home screen and I'm going to take my X and I'm going to show you, okay, X is the 3.097, right? And I'm going to take my X and I'm going to store it. So press the store button, and then I'm going to press alpha app to get the B and press enter. So now my B, if I just press B, B is now this number 3.097. Okay, so I'm going to go back to my paper and I'm going to record that value. So this second value was X is about 3.097, and I'm storing that as B, so I'm going to come out here to the side and go, okay, that is B. B is this number right here. Okay, so we've got our critical values. These are 2 of them, and we have our endpoints. So now it's just a matter of evaluating the function at the endpoints and also at these critical values. So I'm going to find f of -2, and I'm going to do this from smallest to largest, okay? So f of -2, I'm going to figure out what that one's equal to. I'm going to find f of my a, and so I'm just going to write a here, okay? And then f of b, because that's this value right here, and I can do that, and the only reason I can write a and b is because I've told anybody that reading this that what a is and what b is. That's really important, okay? And then finally, we want to find f of 5. Okay, so I'm going to go back to my graphing calculator and I'm going to put these values in. All right. Okay, so now to put these in, I'm going to press alpha trace and I'm going to select number 3 and then put parentheses and we're going to put in -2. And I'm going to press enter. Okay, so that gave you a value of 0. So I'm going to record that on my paper, and I'm not going to go back to my paper, okay, just for the sake of time. Then I'm going to press alpha trace, and then number 3 again. You guys, hold on. I made a mistake. Okay, earlier I did the same problem. My function is not y1. Hold on, I just really messed up. Back up. Okay, so I stored my function. My function is really stored as y1. So we got to be careful, and it's easy to do what I just did. Okay, y1 is my function. So I didn't want to find y3 of 0 or of -2. I actually wanted to find y1. Okay, so go back. Oops, that's not what I want to do. Go back to the home screen. Okay, so here we go. Sorry about that. Press alpha, trace, and we want number 1. And we're going to evaluate that function at -2. And then press enter. Okay, turns out to be 0 also, okay? Just happened to be that way, okay? This one I shouldn't have used this one, all right? Okay, and then we got to do y1 of a, okay, because that'd be f of a. So alpha, trace, number 1, and then parentheses, alpha a, close the parenthesis, and that gives us 16.901. So I'm going to record that. And then we want to do alpha, trace, and y1. And we want to do it at b, so alpha b, and enter. And that's -5.049. So I'm recording that. -5.049. And then finally, alpha trace for number 1, y1. And we want to do this at 6. And then press enter, and we get 64. All right, so now I'm going to go back to my paper, and we'll take a look at this. Okay, so on my paper, I have these 4 values, right? And the 64 is the largest, okay? So that tells me that's the absolute maximum. So we have an absolute maximum of 64 at x equals 5. And then the minimum is this -5.049. So we have an absolute minimum of -5.049 at x equals, and that would be at b, which is 3.097. Or you could put at x equals b if you wanted to, because you told somebody else what b was, okay? All right, so I want to really iterate this with you guys and make sure you understand this. Like, you got to check the endpoints, okay? So when you're given a closed interval and you're asking to find absolute max or absolute min, all right, you got to find the critical numbers. You got to use the endpoints along with the critical numbers and then put them in and see which one's the biggest and which one's the smallest, okay?